All right, today we're going to pull back the curtain on one of the most universal human frustrations out there. Yep, the simple act of waiting in line. And we're going to reveal the powerful, hidden science that's secretly running the whole show.
I mean, of course you have, right? We've all been there. Whether you're at the grocery store, stuck in traffic, it's that feeling where time itself just seems to grind to a halt, just for you. But what if that wait wasn't just a minor annoyance? In some systems, a long wait can be a really critical issue. Imagine you're not waiting for a coffee, but for medical care in a busy hospital's outpatient department, the OPD. In that line, every single minute really matters.
So, this quote actually comes from a study at the Fortis Escorts Hospital in India. A team of researchers there decided to treat these long lines not as some unavoidable fact of life, but as a solvable problem, something you could actually measure, analyze, and, believe it or not, fix.
Okay, so let's dive into this specific case. The research team zeroed right in on that outpatient department because it often has the longest queues in any hospital. They wanted to pinpoint exactly where and, more importantly, why all this time was being wasted.
So, what they find? Well, you might expect the biggest delay to be, some complex medical procedure or a big technical glitch. But look at this. The single biggest time waster was just a simple lack of information. First-time visitors were spending, on average, almost 10 minutes just trying to figure out the registration process.
And just think about what that means. The researchers calculated that by fixing that one simple information gap, they could cut that specific wasted time by almost 44%. That is a huge improvement from a single, totally non-medical change. But that kind of leads to a bigger question, right? How could they be so specific about the savings? And with a few possible fixes on the table, how could they know which one would actually work the best? Well, the answer, believe it or not, comes from a field of math born over a century ago in a telephone company. Way back in 1909, there was this Danish engineer, Agnarr Erlang, and he was studying all the calls overwhelming the Copenhagen Telephone Exchange. He came up with this whole mathematical way to understand and predict these waiting lines, and in the process, he created an entirely new field of study. It's called queuing theory, and it is, quite literally, the science of waiting in line. It gives us the tools to build a mathematical model of any queue, understand how it behaves, and predict how even tiny little changes are going to impact wait times. And this idea just grew up right alongside our technology. For managing phone calls, it was a no-brainer for the first computer networks back in the 60s, which were all about managing queues of data. And today, oh man, its principles are basically in the DNA of our modern world, shaping everything from factory assembly lines to traffic flows and, hospital waiting rooms. At its core, the theory is actually beautifully simple. It sees any queue as a birth-death process. Sounds a little dramatic, but check it out. In our hospital example, a patient arriving is a birth into the system. The time they spend waiting and getting care is their time in the system, and when they leave, that's a death. By modeling the rate of these births and deaths, you can analyze the health of the entire system. Pretty cool, huh? So, queuing theory helped diagnose the problem. But, that's only half the battle. Knowing why people are waiting is one thing, figuring out the absolute best way to fix it, well, that's a whole other level of challenge. I mean, just think about the hospital's registration problem. You could put up better signs, or maybe you create a whole new info desk, or maybe you just retrain the staff on a new workflow. Every one of those solutions has different costs, different complexities, and different potential payoffs. Now, you can't just try each solution one by one in a live hospital. Can you imagine the chaos and the expense? You need a way to test all the possibilities at once to find the proven, optimal choice before you change a single thing in the real world. And this is where we move from just analyzing the problem to actively solving it with a seriously powerful modern tool for making decisions. It's called simulation optimization. And the best way to think about it is like creating a digital twin of your system, a perfect virtual copy of the hospital or a factory or a traffic grid. Then, in that safe virtual world, you can run thousands of experiments, testing every potential solution to see which one delivers the absolute best results. So instead of that old-fashioned and kind of risky trial and error approach, you can test everything virtually. It's really the difference between just guessing and actually knowing. One of the cleverest ways to do this is a method called a ranking and selection. Think of it like a virtual bake-off, okay? First, you list out all your recipes. Those are your potential solutions. Then, you run a quick simulation for every single one, just to get a taste. You throw out the bad ones, and you dedicate more and more computer power to the recipes that seem the most promising, until a statistically proven winner emerges. So, this powerful combination of queuing theory and simulation optimization, it's not just a solution for one hospital. It's a blueprint. And this kind of math is secretly and silently running the world all around us. For instance, the timing of traffic lights in your city, that's simulation optimization, trying to find the perfect flow to cut down your commute. Or how a company knows exactly how many people to have working a call center during that lunch rush, that's queuing theory. This is the math behind global supply chains, factory layouts, even those complex financial risk models. What these tools really do at the end of the day is they make the invisible math of our world visible. They give us a way to understand the complex, sometimes chaotic systems we live in, and then engineer them to be more efficient, more effective, and a whole lot less frustrating for all of us. So the next time you find yourself stuck in a line, look around. Think about that hidden system at play, and ask yourself, if you had these tools, what's the first part of your daily life you would optimize?